In India, there are many places where the train track crosses the road. Do you know what such places are called? It is called a level crossing. Now, in most places in India, level crossings do not have camera surveillance. So, let's say a girl, she wants to cross the level crossing where the train track meets the road. And there is a train that is approaching. But since there is no camera surveillance, she doesn't know where the train is. So will she be able to hear the sound of the train if she stands like this? She will not. Now let us see how she can know that the train is approaching. What she does is, she lays her head on the track and keeps her ears on one of the tracks. Now she can distinctly hear the sound of the approaching train, and this way she knows whether it is safe to cross or not. Can you tell me what happened? Let us find out. Notice this animation. In this animation, you will find that a parcel is being passed from one end of the room to the other end in between three people. You will observe that the time being taken for the parcel to pass from one end to the other is 6 seconds. Now, what happens if there are more number of people in the room? Let us find out. In this example, you find there are 6 people who are passing the parcel from one end of the room to the other. Notice that the time being taken for the parcel to cross from one end to the other is only 3 seconds. Now, can you tell me which time is lesser? Obviously, when the parcel is being passed between 6 people. So, what exactly is happening? Let us take a closer look at the three states of matter. On the board, you find a picture of the molecular distribution of the three states of matter. Here you find that in solids, the molecules are packed very closely to one another. In liquids, the molecules are relatively loosely packed. And in gases, the molecules are far apart. So we had learned that sound is nothing but the traveling of disturbances due to molecular vibration of the medium. So in solids, there are more molecules and they are very closely packed. And in gases, the molecules are loosely packed. So what do you think happens when sound travels through these media? Let us find out. In the previous animation, we saw that in a given space, when there are less number of people, the parcel takes a longer time to be passed from one end to the other. However, in the same space, if there are more number of people, then the parcel takes a shorter time to pass from one end to the other. A similar case happens in case of the states of matter. We consider solids, liquids, and gases. And we find that a disturbance is traveling from one end of the medium to the other end. Now, if you look closely, you will see that in solids, the molecules are very densely packed. So a sound disturbance takes a very short time to pass from one end to the other in this direction. Come to liquids now. You will find that the molecules are relatively less densely packed. So we can say that the sound disturbance takes a longer time to pass than in solids. And if you consider gases, you will find that the molecules are very sparsely packed. What does this imply? This implies that the sound disturbance traveling through gases will take a much longer time than liquids or solids to pass from one point to the other. We can conclude that the velocity of sound in solids is greater than the velocity of sound in liquids, and that in turn is greater than the velocity of sound in gases. Over here, V solids indicates velocity of sound in solids, V liquids indicates velocity of sound in liquids, and V gases indicates velocity of sound in gases. And the relation, as I just mentioned, is given by this expression. So let us look into a little bit of additional information. The velocity of sound in steel, which is a solid, is 5100 meters per second. The velocity of sound in water, which is a liquid, is 1450 meters per second. And the velocity of sound in air, which is a gas, is 330 meters per second. Now you can see that the velocity of sound in water is almost 5 times that in air, and the velocity of sound in steel is almost 4 times that in water. So let's take a quick recapitulation of what we learned. We learned that sound is a disturbance that travels through molecular vibrations of the medium. In solids, the molecules are very closely packed. In liquids, they are relatively loosely packed. And in gases, they are very far apart. So sound in solids travels faster than it travels in liquids, and sound in liquid travels faster than it travels in gases. And as you can see from the board, the velocity of sound in steel is 5100 meters per second. The velocity of sound in water is 1450 meters per second. And the velocity of sound in air is 330 meters per second. So now we can answer why the girl was unable to hear the sound of the approaching train when she heard it in air, but she was able to hear it once she laid her ear on the track. As you can clearly see, the velocity of sound in steel is 5100 meters per second, and the train tracks are made of steel, whereas the velocity of sound in air is 330 meters per second. So you can clearly see that sound will travel much faster along the train tracks than in air. So it is due to this reason that when the girl laid her ear on the tracks, she was able to hear the sound of the approaching train, because the sound traveled much faster than when she tried to hear it in air.